Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 4 we are going to discuss one another chemical properties, what we say here, that is reactivity towards oxygen, right? So when we talk about the group 15 elements form two types of oxide. The two types of oxide are E2O3 and E2O5, what we call it as O5, sorry. E2O3 and E2O5. Understood? That is, you can see in your textbook it is given E2O3 and E2O5 means what? N2O3 and N2O5. Now when we say E, can be nitrogen, phosphorus, arsenic, antimony, and like this what we say. Understood? So now when we talk about also bismuth also forms oxide because it is a metal, what we say. E can be any of these. Understood? Now in this case, when we say in this case nitrogen is diatomic, I think that everyone know and we have discussed already, but the oxide in higher oxidation state, this you can remember as a point. The oxide in higher oxidation state, oxide in higher oxidation state, what you call it as, of the element is more acidic in nature. Now for that, if we write one example, that is N2O3 and when we write N2O5, what we say. Understood? Now when you find the oxidation number of N2O3, in that nitrogen oxidation is +3, and when you find of N2O5, nitrogen oxidation is +5, what we say, right? So therefore we can write here, therefore N2O5 is more acidic in nature, what we say. Means the oxidation state of the elements of group 15, higher oxidation state elements are more acidic in nature. So this one is a very important topic or a question you need to remember. That is of acidic state, when we say the oxides with higher oxidation state, that is of group 15 elements, nitrogen I am talking about, I give an example, this you can write down in your fair book. So with higher oxidation state are more acidic in nature. Understood? Now when we talk about the oxides of this type, that is E2O5 type, that we are going to discuss next. I will just rub this part, just a minute, this you can write it down. Understood? Okay, now the next part. Now, when we talk about this type of N2O5 type of oxide, when we say N2O5, so in this case, when we talk about of this type, it can be N2O5, P2O5, ES2O5. Understood? I think in your textbook it is given on page number 173. ES2O5, then SB2O5 and Bi2O5, like this what we say. Understood? So in this case, when we say, in this case, this one, the characteristic or the behavior, when we write of N2O5, the N2O5 is acidic in nature. Here I am talking about this particular type of oxide, N2O5. Just a minute. N2O5, what we say, is what we call it as acidic in nature. When we talk about this P2O5, when we say P2O5 is also acidic. Clear? This 2, when we say, is amphoteric oxide. Amphoteric, what we say, amphoteric means it behaves like an acid as well as a base, with both acid and base, what we say. And the last one, what we say, it is a metallic oxide. This is non-metal oxide. So we know non-metallic oxides are acidic in nature. This one are metalloid, so they are amphoteric in nature. But this one, what we say, this is metalloid. Clear? This one, arsenic and SB. Bismuth is a metal. Okay, so metal oxide, we know they are is basic in nature. Basic. Understood? So I think this part you understood, and you can write it down. This can be asked in MCQ. What we say, that is the oxides which are acidic, which are basic, and which are amphoteric. Understood this part? But this is a particular, that is E2O5. I gave an example of E2O3, that the higher oxidation state of that element of group 15, which one is more acidic in nature. Okay. Now the next topic is reactivity towards halogen. What is the next topic? Reactivity towards halogen. What we say? Reactivity towards halogen. Okay. Now when we talk about this reactivity towards halogen, they form two types. Group 15 elements form two types of halides. Two types of halides. Now if you see which are the two types of halide, it is of EX3 type and EX5 type. Yeah, these are the two types of halide which they form. Okay, now the next part. Okay, now when we talk about this, this pentahalide, this is trihalide, these are called trihalides, and these are called pentahalides. Penta is for 5, what we said, tri for 3. Okay, so nitrogen, remember this thing, important, that nitrogen does not form pentahalides because of unavailability. What we call it is because of unavailability or non-availability of d orbital. Okay, this is the reason why it does not form. Nitrogen does not form pentahalide. So this you have to remember. Okay, then another one thing, that is pentahalides. Pentahalides, that is this type of halides. What we said here, E can be nitrogen, phosphorus, arsenic, antimony, like this. What we say. Now pentahalide form, penta is what we call it as 5. 5 pentahalides are more covalent than trihalides. Clear? Now what is the reason why pentahalides are more covalent than trihalides? So this is due to the fact that pentahalide have +5 oxidation state. Clear? While trihalide, when we say, have +3 oxidation state. Clear? Now this thing I think you must have heard about. This +5 and +3 oxidation state mean by loss of 5 electron, and here by loss of 3 electrons. So they form because of this. That is trihalide have +3. Since element, what we call it as, in your textbook you can see on page 173 one reason is given, that is the element in +5 oxidation state will have more polarizing power than +3 oxidation state. Is this what I am talking about? This will have more polarizing power. More polarizing power means it forms ions. In this case, what we call it forms what? Just a minute. It forms ions, what we say. Understood this part? Is it clear? So it easily form ions. So that is more polarizing power than in +3 oxidation state, and the covalent characteristic of the bond is more in pentahalide. Now what is this all? We will be studying in the further topics when we are going to discuss what we said. Understood? Now there is another topic is also given. The trihalide of this element except those of nitrogen are stable, and in the case of nitrogen only the halide which is known is only NF3, what we call it. That is a stable halide. Which is the word? Stable halide in nitrogen is NF3, what we call it. A stable halide in nitrogen is NF3. Then trihalide except BiF3 are predominantly covalent in nature. That is BiF3. Okay, now that topic again we will discuss later, but I think this part I think it is clear. Two types of halides are formed, EX3 type and EX5 type, in which nitrogen does not form this type of halide because of the non-availability of d orbital. Pentahalides are more covalent than trihalide because of the oxidation state of pentahalide is +5 and that of trihalide is +3. This will have more polarizing power compared to trihalide. Okay, now this was all about reactivity towards halogen. Now the last part in your chemical reactivity is reactivity towards metal. What is the word? Reactivity towards metal, that we are going to discuss next. Reactivity towards metal. Reactivity towards metal. Okay. Now when we talk about this reactivity towards metal, now in your book all these elements react with metal to form binary compound. All elements, what we call of group 15 forms react with metal to form binary. What is the word? Binary. Now what is binary means? Two. Binary means what you call to form binary compound exhibiting -3 oxidation state. Clear? Now exhibiting -3 oxidation state, what we call it. Now when we talk about binary, what we say here, you can see one example, calcium Ca3N2, what we call. Understood? And another, that is calcium nitride. What is this? Calcium nitride. Okay, then Ca3P2. Understood? Now, okay, now in this case when we write here calcium, it is +2 oxidation state. So +2 into 3 will be +6, and nitrogen 3 -3 into 2, so -6. So you can see here exhibiting -3, and binary means this 2, what we call it as. Okay, so these are the binary compound exhibit. Binary means 2 elements you are used here. You can see Ca3N2. So in this case nitrogen oxidation state is -3. Same way for phosphorus it is -3. So this is calcium phosphide. Calcium phosphide. Okay, so I think calcium nitride and calcium phosphide you understood. Same way sodium arsenide, that is Na3, I think sodium arsenide, Na3As. Okay, because sodium it is +1 into 3 means +3. Now here and arsenide is -3, so sodium arsenide. Okay, so here arsenic acid, you can see -3 oxidation state is there. Same way another zinc antimonide also is there, that is Zn3Sb right, it is Zn3 zinc antimonide. Understood? So in this case also Sb, that is antimony, will be having -3 oxidation state. Zinc is +1 into 3, so +3 and -3 both average oxidation state will be 0 in this case. So that is zinc antimonide. Then one more example we can write in this case also. Zinc antimonide, I think in a textbook many are given. Magnesium bismuthide is also given, that is Mg3Bi2. Okay, Mg3Bi2, that is magnesium bismuthide. Okay, so in this case also bismuth it is -3 and magnesium +2 into 3 and bismuth -3 into 2. So this is +6 and -6. So total oxidation state will be 0. So these are the binary compound exhibiting -3 oxidation state of group 15 elements. Understood this part? So this is the reactivity with the metals what we talk about. They form binary compound
exhibiting -3 oxidation state. Okay, so here we come to an end of chemical properties what we have discussed. Next time we will be discussing about what we call it as the preparation of dinitrogen is the topic what we are discussing in our next video. Then preparation of ammonia is there, oxides of nitrogen what is given there, nitric acid, many things are there. So one by one we will be discussing according to your textbook topics only. We will not discuss from here and there. We will go through as what you call same pattern what is given in your textbook. So this all things what we have seen, what we have written, you can see here, you can write down in your fair book. These are the questions which can be asked in board for 1 mark also and for 2 marks also. Understood? So this was the thing what we discussed today. So here till then we will stop our video here. Next time we will be continuing with our next videos, that is of preparation of dinitrogen. Okay? Thank you very much.